So this is our first equation, and then we have our second equation. Using these two, we can tackle any kind of binomial expansion question, easy, medium, or difficult. Hey everyone, George here. This is part 1 of binomial expansions. Okay, so before we start, there are 2 foundational concepts that we must know to be able to tackle the easiest right up to the hardest type of binomial question. So first things first, let's quickly go through that. Okay, so for this first equation, we have a plus b to the power of n equals a to the n plus n1 times a to the n minus 1 times b plus n2 times a to the n minus 2 times b squared, and so on until we reach b to the power of n. Now you would get this kind of equation or something similar to it in your textbooks. Some of you may be wondering, what does n1, n2 and n3 mean? Essentially, they can be rewritten as nc1, nc2 and nc3. So what does that mean? We can rewrite it as ncr, n is a number, r is a number, equal to n factorial, factorial is the exclamation mark, over r factorial multiplied by n minus r factorial. Now some of you may be wondering, well, what does factorial mean? As an example, 4 factorial is equal to 1 times 2 times 3 times 4, and as another example, 3 factorial is 1 times 2 times 3. So 4 factorial is 1 times 2 times 3 times 4, that's 24, and 3 factorial, as you can see, that would equal to 6. So I'm just going to box this right now. We would be needing this for sure. So now with this knowledge in hand, we can now rewrite our equation as a plus b to the power of n equals a to the n plus nc1 times a to the n minus 1 times b plus nc2 times a to the n minus 2 times b squared plus nc3 times a to the n minus 3 times b cubed. And we can keep going on and on until we reach essentially ncn multiplied by a to the power of n minus n times b to the power of n. Now actually, ncn would be equal to 1. N can be any number. Let's say you had 3c3, 4c4, 5c5, it would still all equal to 1. A to the power of n minus n, well that's essentially a to the power of 0, right? And that's always going to be equal to 1. So we can tidy that out of the way and we will essentially be left with b to the power of n as the last term of that binomial expansion. So if we tidy up our equation, we have a plus b to the power of n going on as normal, with the last term at the end as b to the power of n. So this is our first equation that we would definitely need to know to be able to do any kind of calculations for binomial expansion in AS. And then we have our second equation that we would need to know. Using these two, we can tackle any kind of binomial expansion question, easy, medium, or difficult. So with that out of the way, let's go into the easy level questions now. Okay, so number 1, use the binomial theorem to find an expansion of 3 minus 2x to the power of 5. First of all, we're going to use that same binomial expansion equation that we have already established, which means that we can now put 3 minus 2x to the power of 5 into a plus b to the power of n. That means a would be equal to 3, b would be equal to minus 2x, and n would be equal to 5. Plugging in all the necessary numbers into the equation, we start out by first getting 3 to the power of 5 plus 5c1 multiplied by 3 to the 4 times minus 2x plus 5c2 multiplied by 3 cubed, then multiplying by minus 2x squared. Adding on to that, we have for the next term 5c3 times 3 squared times minus 2x cubed, plus for the next term we've got 5c4 multiplied by 3 to the 1 times minus 2x to the power of 4. And then adding on lastly, we have 5c5 times 3 to the 0 times minus 2x to the power of 5. And that's probably the hardest part of this kind of question. So now to simplify this further, 3 to the power of 5 is 243, plus 5c1 which is 5, multiplied by 3 to the power of 4 which is 81, times minus 2x. Adding on for the next term, we have 5c2 which is 10, multiplied by 3 cubed which is 27, multiplied by minus 2 squared which gives us 4x squared, plus 5c3 which is 10, 3 squared which is 9, minus 2x cubed, which is just minus 8x cubed, plus 5c4, which is 5, 3 to the power of 1, which is just 3, we should know that, multiplied by minus 2x to the power of 4, which is just 16x to the power of 4. Adding on for our last term, we have 5c5, which is just 1, multiplied by 3 to the power of 0, which is again just 1, and then we're multiplying by minus 2x to the power of 5, which gives us minus 32x to the power of 5. Now, as you have already guessed, in the last term, we can just cancel out the 1s because 1 times minus 32x to the power of 5 just gives us minus 32x to the power of 5, which is indeed b to the power of n anyway. And finally, simplifying everything for the final time, we have 243 take away 5 times 81 times minus 2x, which is minus 810x, plus 1080x squared minus 720x cubed plus 240x to the power of 4 minus 32x to the power of 5. And that's it. We have fully just expanded this binomial expansion. Okay, onward to question 2. We want to expand 1 minus 2x to the power of 10 in ascending powers of x up to and including the term x cubed, simplifying each coefficient in the expansion. Now, when they ask us, okay, we wanted to expand it up to including the term x cubed, essentially means when we do expand 1 minus 2x to the power of 10, we're going to get something plus something x plus something x squared plus something x cubed, and then it will carry on. However, because we are only asked to expand up to the term x cubed, we can just stop right up to there. This makes everything nice and easy for us. So to expand this using the binomial expansion formula that we know, 1 minus 2x to the power of 10 gives us 1 plus 10c1 times 1 to the 10 times minus 2x. In next term, 10c2 times 1 to the power of 9 times minus 2x squared plus 10c3 multiplied by 1 to the 8 times minus 2x cubed. We can go further, but because of the question we don't have to. Now to simplify this even more, we have 1 plus 10c1 is 10, 1 to the power of 10 is just 1, so we don't even have to include that now, times minus 2x plus 10c2, which is 45, multiplied by minus 2x squared. And for the fourth and final term, we have 10c3, which is 120, which we're multiplying by minus 2x cubed. And then to finally expand this in its final form, we've got 1 minus 20x plus 180x squared minus 960x cubed. And there we have it. We have expanded our second question. It wasn't that bad. You're just plugging numbers into a formula. That's it. Okay, so for our third question in the easy section, this one's a bit more interesting. We need to use the Binomial Expansion Theorem to find the first 4 terms in the expansion of 2x minus a third y all to the power of 9. So once again, we're just going to use our binomial expansion formula. That's going to equal to 2x to the power of 9 plus 9c1 times 2x to the 8 times minus a third y plus 9c2 multiplied by 2x to the power of 7 times minus a third y squared plus 9c3 times 2x to the power of 6 multiplied by minus a third y all cubed. Again, we can go further on. We don't have to. They only want the first 4 terms. And now to simplify this further, make it more nice. 2x to the power of 9 simplifies to 512x to the 9 plus 9c1, which is 9, times 2x to the 8, which is 256x to the power of 8, multiplied by minus a third y. For the next term, we add on 9c2, which is 36, multiplied by 2x to the 7, which is 128x to the 7, multiplied by minus a third y squared, which gives us 1/9 y squared. And for the final term, we have 9c3, which is equal to 84, multiplied by 2x to the power 6, which gives us 64x to the power 6, multiplied by minus a third y all cubed, which gives us minus 1/27 y cubed. And now for the really lovely part, we just want to simplify this as fully as possible. We have 512x to the power of 9 plus 9 times 256x to the 8 times minus a third y gives us minus 768 times x to the power of 8y. Add 512x to the 7y squared minus now finally 1792 over 9 multiplied by x to the 6 times y squared. And that's it. That final expansion, 2x minus the third y to the power of 9, it may look intimidating, but guess what? We're just using the same method as the other two questions. Nothing has changed. And if we do get that in our exams, we should be absolutely excited. Music to our ears. And that pretty much covers the base level. Big respect for tuning in all this way. Thank you very much, guys. I dare you to check in the other binomial videos that I have done for harder levels. And that's it for today. If you have found the questions helpful, please give us a like, subscribe, and comment on the video. If you didn't find it helpful, also comment on the video. I want to know your thoughts. Finally, if you are looking for maths tuition, I have my details right here. And that's it for today. Thank you very much. George out.